Hello everyone, welcome to video number 5 of AP Computer Science A. In this video, you're going to be learning about searching algorithms and sorting algorithms. So first of all, searching algorithms. Searching algorithms find the index of a certain element inside of an array or other collection such as array lists. The simplest searching algorithm is linear search, and the way that works is it starts from the left and going right. It checks every element until it arrives at the desired element, and then it returns the index. If the desired element is not found anywhere inside of the collection, then it returns -1. The way that the optional exercise is going to work for this video is I'm going to tell you how an algorithm works, and then you can code it up if you want. So if you want to try to code up linear search, then pause the video here and then keep watching when you're done. Here is the solution. So I already have the collection initialized, and to scan through every element, we can just use a for loop. We start from the left, index 0, and then go to the right. Inside of the for loop, we can say if the element at index A of collection is equal to 2, that's what we're trying to find, then we print out index, and then after that we can just stop the code, so we say return. And then if we reach the end of the for loop, so if we haven't found the element anywhere, then we print out -1. Let's run this. And it prints out 5, which is the correct answer. The next searching algorithm is called binary search. And binary search is faster than linear search, but it can only be used on sorted collections. The way that binary search works is it starts by checking the element in the middle, and if it's lower than the element we're trying to find, then it eliminates that element and everything to the left. If it's higher, then it eliminates that element and everything to the right. And it keeps on doing this, checking in the middle and shrinking the range each time until it finds the element that we're trying to find. And if our element is not found anywhere, then it returns -1. So here's an animation of how it works. All right, so if you want to try to code up binary search, then pause the video here and give it a try. Here is the solution. So first, we need 2 variables to keep track of the lower bound and the upper bound. The lower bound will be index 0, and the upper bound will be the last index, and that is the length of the collection -1. All right, and then we can use while loop, and we can say while true. That might look like an infinite loop, but don't worry, we're going to be using the return statement. And first we need the middle. So the middle will just be the lower bound plus the upper bound. And then divide by 2. And the element at index middle of collection is equal to the element that we're trying to find, which is 5. Then we print out the index, and then we return. Otherwise, if the element is greater than 5, then we set the upper bound to middle and -1. You need the -1 because you're also eliminating the element that you're searching. You're not just eliminating everything to the right, you're also eliminating the current element. And then else, so if the element is lower than 5, then we set lower bound to middle +1. All right, and then now what if our element doesn't appear in the collection? Well, in that case, this algorithm is going to continue searching until even when the lower bound becomes greater than the upper bound. So we can just say if lower bound is greater than upper bound, then print out -1 and return. So let's run this. And it prints out 2. That's the correct answer. Now we're moving on to sorting algorithms. Sorting algorithms do exactly what their name suggests. They sort the elements of a collection from the lowest to the highest. Today we will be learning about 3 sorting algorithms. They are the easiest sorting algorithms to code up, but they're also slow. In a future video, we will learn about some fast sorting algorithms. So the first sorting algorithm is called bubble sort. And the way that works is it goes from left to right, scanning 2 adjacent elements at a time. And if the first element is greater than the second, it swaps them. But after one iteration, the collection is not necessarily sorted. So this process is repeated. And when does it stop? It stops when an iteration has passed where no swaps have been made. So how this works is there is a boolean called sorted, and this boolean is set to true at the beginning of each iteration, and every time a swap is made, this boolean is set to false. And once there has been an iteration where the boolean remains true at the end of the iteration, the process stops. So now let's see an animation of how bubble sort works. All right, now that you know how bubble sort works, if you want to try to code it up, then pause the video here and then keep watching when you're finished. Here is the solution. So first we need a boolean called sorted. And we set it to false at the beginning because we're going to be using a while loop, and we're going to say while not sorted. If we set it to true at the beginning, then this while loop will not run even once. So at the beginning of the while loop, we set sorted to true, and then we use a for loop to scan through every adjacent pair of elements in the collection. And we say if collection A is greater than collection A plus 1, then we swap them. We first need a variable to keep track of what collection A is. And then we set collection A to collection A plus 1. And then we set collection A plus 1 to what collection A originally was. And don't forget to set sorted to false. And then at the end of the while loop, let's just print out each element of this collection just to make sure we sorted it properly. All right, we sorted this properly. The next sorting algorithm is called insertion sort. And the way that works is it goes from left to right, and for each element, it inserts it into the right place. So how that works is it moves the element left until it is greater than the element to the left of it. So here is an animation of how it works. All right, so now that you know how insertion sort works, if you want to code it up, then pause the video here. Here is the solution. So we need to scan through each element from left to right, so we can use a for loop. And then inside, well, for each element, we need to move it left until it arrives at the proper place. So we can use another for loop for int b equals a, and then b is greater than 0, b minus minus. That allows us to move the current element left, and we say if collection b is less than the element that's before it, collection b minus 1, then we swap them. So we first need a variable to keep track of collection b minus 1, and then we set collection b minus 1 to collection b, and we set collection b to what collection b minus 1 originally was. Else, so if the current element, if collection b is greater than or equal to the element to the left, that means it's already in its proper place. So we can just break out of this inside for loop. All right, and then after this code runs, let's just print out each element of collection to make sure that we sorted it properly. All right, so it sorted it correctly. The last sorting algorithm for this video is called selection sort. And the way that works is it goes from left to right, and for each spot, it scans the element in that spot and everything to the right. And it keeps track of the lowest element it sees and the index of the lowest element. And when it's done scanning through the current element and everything to the right, it swaps the lowest element with the element in the current spot. So let's see an animation of how that works. All right, now that you know how selection sort works, if you want to try to code it up, then pause the video here. Here is the solution. So first we need two variables to keep track of the lowest element and the index. And then we use a for loop to scan from left to right. So inside the for loop, we first set lowest to the element at the current spot. And we set index of lowest to A, and then we use a for loop to scan through everything to the right. So B equals A plus 1. And we say if the current element, if collection B is less than lowest, and we set lowest to collection B and set index of lowest to B. And then after this inside for loop runs, we swap. So first we say collection index of lowest equals the element at the current spot, which is collection A, and then collection A equals lowest. And then after this, let's just print everything out. All right, it prints out exactly what it was supposed to do. So remember these 5 algorithms: linear search, binary search, bubble sort, insertion sort, and selection sort. In a future video, you will learn how to easily and quickly sort a collection, but if you need to use a sorting algorithm before then, just pick the one that you think is the easiest to code. If you really don't care and want to use the fastest one, Just know that their runtimes are very similar, but in general, insertion sort is the fastest, followed by selection sort and then bubble sort, but that's not always the case. But this is not important to remember. What's important to remember is that these three algorithms are all slow, and in a future video, we will learn about two fast ones. But anyway, I hope you enjoyed, and I'll see you in video number 6.